So let's look at a graded potential. Now, a graded potential is a small or trivial fluctuation in the membrane potential. Okay, it's very small. It's like a little blip or a little blur, right? And this is where the membrane potential can either depolarize or hyperpolarize, but it's very small and it communicates over a very short distance of time. Okay? When compared to an action potential is larger. It's much stronger in magnitude, and it can communicate over a very long distance. Think about some of the length of the nerve that action potentials communicate across. The sciatic nerve, which is a very long nerve. The radial nerve, which goes all the way through your upper limb, right? So action potentials move across a longer distance. They're bigger in terms of their magnitude, whereas graded potentials are smaller, right? Less significant, and they communicate over much shorter distances. So graded potentials are initiated by a stimulus. You have a question?
Yeah. Graded potential is only during depolarization and hyperpolarization.
So graded potentials are small. They can be depolarizations, which are increase, or hyperpolarization, not repolarization.
Okay.
Because repolarization would imply that we had an action potential. And graded potentials are not action potentials. Let's make that clear. Okay? Several graded potentials can come together and generate an action potential, but a graded potential is not an action potential. Right? Now, it's initiated by a stimulus, and a stimulus can be anything from a neurotransmitter being released at a synapse. It can also be a physical stimulus. If you touch something that's hot, if you see a visual stimulus, you smell something, that would be an olfactory or an auditory, so whatever type of stimulus. And then we have a small change in the membrane potential. Now again, for point of reference, our resting membrane potential is -70 millivolts. So even the smallest bump in that membrane potential, if we bump it up to -60, that's a graded potential. Okay? Now the magnitude can vary. It can be small, it can be big, but the important thing here is that we're not reaching that threshold to stimulate full action. The spread of a graded potential happens by electrotonic conduction. Electrotonic conduction simply means that ions are moving across the membrane, and that's how we generate some electrical energy. The movement of these ions that we spoke about across the plasma membrane. And this is why the graded potential is decremental. Decremental means that it's going to diminish or decay over time. So if you stimulate a nerve and you have a small bump in the membrane potential, you have a graded potential, it's not going to get very far. It's going to get to about the axon hillock, that neuron. Right, so I'll point this out. So you have a stimulus here, and then it's going to propagate not very far again, just about to the axon hillock. Okay, and that happens because, think about the analogy of water moving through a faulty or a leaky hose, right, as opposed to water moving through an intact hose. As water moves through that hose, if there are leaks in that hose, you're going to lose some of that water. That's the same thing that happens here. So as that graded potential travels down the axon, we lose some of that electrical energy because some of these ions move across the membrane. Ready? Now, the purpose of graded potentials is to determine whether or not we will reach threshold, whether or not we can stimulate an action potential. And so basically, you may have a positive or an excitatory graded potential, or you can have an inhibitory graded potential. And that will determine whether or not you were able to stimulate an action potential. In the case of an inhibitory graded potential, this makes it harder. This makes it much more difficult for an action potential to be initiated. And we're going to see this when you look at the cardiovascular system. The parasympathetic system has an inhibitory effect on the heart, and so it makes it hard to fire an action potential. And that is the idea behind an inhibitory graded potential. Now, when we do reach threshold, there is a level of depolarization that is required to get to threshold. And we're going to talk about that number. That number is negative 55. Okay? When we get to negative 55, this is an all or none phenomenon. We will definitely, for sure, generate an action potential. But if we do not, it's just a graded potential. Okay? All right, any questions? Okay, now these graded potentials have the ability to sum or to add onto one another, and this is what we call summation. There are two types of summation. There's temporal summation and there is spatial summation. So temporal summation is if you have the same stimulus, all right, and what you have is a repeat in the membrane potential change that is relatively close together in time. So you have a stimulus here, you have a bump in the membrane potential, another stimulus here, another bump in the membrane potential, right? And then you fire an action potential. These two very small stimuli summated or added onto each other. Spatial summation is different. You have two different types of stimuli, right? Two different types of stimuli. So this example, you have a depolarizing stimulus and a hyperpolarizing stimulus. So the depolarizing is W, the hyperpolarizing is Y. And when you add those two different stimuli together, you get W plus Y, and these basically overlap in time. Here we did not generate an action potential, again, because of that inhibitory stimulus, which sort of impedes us or blocks us from getting to an action potential. Alrighty? If these were two positive stimuli, then you would generate an action potential. So that's temporal summation and spatial summation. Temporal is going to be the same stimulus. Spatial is going to be two different types of stimuli.